Hey everyone, welcome to another Python video. In this video, we'll be solving the string compression problem. We're going to implement a function that performs a basic string compression using the counts of repeated characters. We're going to return the string if the compression is longer or the same length as the argument. So for example, if we have this string here, A is repeated twice, so we have A of 2. B is only repeated once, so we have B1. We have 5 C's, so we have 3, 5. And we have 3 A's, so we're going to have A3 as our testing value. So I call this function a string zip because we're compressing a string. We started off with an empty variable of a string, empty string variable, where we're going to grow this variable called result. And our counter is 1. We're going to be assuming that if we have this counter or looking at this A value here, well, we have one of them so far. We just want to see how many exist so far, and then we'll do some conditionals. So we're going to be iterating through based on an index. Okay, we're going to start at 1. So if I'm analyzing this code or this string, I'm looking at this value of A. Okay, then I compare it to the one that comes before it, which is this one, and they're equal. So if anytime the current value that I'm looking at is the same value of the left previous value, we're going to increase our counter, and then we continue on with our loop. But if we're analyzing a situation like this, where my current value is not equal to the left previous value, then we go into our else, right? I add in that left text that I've analyzed, and I also add in the string version of our counter, right? So in this case, there was 2 A's, so our counter loop should be 2. So we added A and 2 to our empty string result, and then our counter is reset to 1. Then we will be looking at C and B, right? In this scenario, this is not true. So B, we're going to add in B, and the counter would only be 1, and then we reset the counter to 1, and now we're at C. And we're going to make at a situation where these two C's are equal to each other, these two C's are equal to each other, and these two C's are equal to each other. So it's going to be just growing until we got to here, where this section would be triggered, where we would say, well, this we saw it 5 times, so we do a string of 5, and then we add that C in 5, so we will get something like that, and we reset our counter, and we get to finish our A. Now what happens is, in a situation, we have 2 situations. Is either if I had a text like this, all of these 3 A's would have been added to our result because of this final difference, and we didn't get to add it. So we have to now account for the final one. Or we got to the point where it was all the same at the end and the counter's been increased, but we just weren't able to add in that last value because this else portion did not get executed. Therefore, after our final iteration of the loop, we must concatenate the last character and the frequency of that. So we just end up doing result plus equals the last character plus the frequency of that, which either would have been 1 or it has been increased and we would just never had a chance to add it. Okay. And at the very bottom of our code or our function, we're going to return either result or text. And this happens when, if the length of the compression is less than the length of the original text, well, we can now return this compressed string. Otherwise, it is just better for us to not compress it at all. So we're just going to return the text back as our argument. So if we test out this code, I have 6 test cases here and our expected values for these test cases. Okay, so then we're just running a loop to test our function, and we have passed all of them because we're getting our expected output for each one of them. All right, so that was a solution to our string compression problem. I hope you enjoyed this video. This one was a little more complex on the other string based problems that we've done. So please take a look at this code of how we use a for loop and the indexing of strings to help us solve this problem. And as always, thank you for watching and stay classy.